Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ikmal bin Masalvi. My number metric is AA191616 from section 1, electronic. So I will introduce you for our lab, our first lab, which is diet characteristic. So let's go for the first question, which is part 1, diet terminals identification and resistance measurement. So the question is asking about measure the resistance value, high or low of the given diet using the analog ohmmeter and identify the anode and cathode terminals of the diet. With appropriate diagram, explain briefly how the terminals of the diet are determined. So these are my diagram that I draw. So let's go for the first one, which is here which is for forward bias. So if the diode are connected with the right polarities, which is positive from anode goes to anode, and negative polarities of ohmmeter goes to cathode of diode, the ohmmeter will produce a value of resistance in diode. So if silicon diode, you will get 600 plus plus. So let's go for the reverse bias. If the diode are connected in the wrong polarities, which is positive goes to cathode and the negative goes to anode, the resistance will give a value of low, or it will give a produce of high or max, because the resistance are very high. So let's go for the B, with the lab B. It shows that the question is about weight an analog ohmmeter set to the X1 range measure the resistance of a 1M4001 in either direction. The polarity of the red and black list of the ohmmeter doesn't matter because the red list may be positive or negative, and so on. So these are wrong. If we see in the purchase, when we try for the run, the reverse bias for diode 1N4001 should be max, and the forward resistance for 1004 should be 614.37 ohm, and the diode for germanium diode, the forward bias is 365.96 ohm. That's a for forward bias resistance. For the value for reverse bias for diode germanium, it will go max, which is the resistance for reverse bias for diode AA119 is very high because it reverse bias. So let's continue for the part 2, IV characteristic of the diode. So the question is about construct the circuit shown in figure 4 using diode, silicon diode. Verify the ID from 0 mA up to 12 mA by varying the value of Vs. Record ID and VD in table 1.3. Repeat for the germanium diode, and plot the ID versus VD for characteristic for both diode on the same graph. So in this figure 4, we can see that the diodes are in forward bias. So the measurement that I get for ID and VD is here, and I use 1 volt for each of bots. So 1 volt for bots number 1, 2 volt for bots number 2, and so on until I get 12 volt for voltage source. So let's try for the so I try for 1 volt and I continue for the 100% pot, and the voltage I get at silicon diode is 0.58 volt, and the current flow after the diode is 0.42 milliampere. So the record I get is same. So I continue until I get 12 volt. So I just use 12 volt. With the 12 volt, I will get 0.71 volts for diode silicon, and the current flow is 11.3 milliampere. So the results are same with my table measurement. And the diode silicon, the germanium diode also, I use the same measurement, 1 volt, so 1 volt. The 12 volts is about 1.5 volt, and the current flow diode germanium diode is 11.0 milliampere. So it's same. So the graph should be look like this for diode silicon diode. Because of forward bias, the graph should be at the positive. So the knee voltage of the silicon diode is 0.58 volt knee voltage, and the knee voltage for germanium diode is 0.69. 0.31 is for current flow through it. So let's continue for the B. So let's continue for the next question. B. Use ID minus VD for characteristic graph in A to measure the DC resistance at ID equal to 1 milliampere and ID equal to 4 milliampere for silicon diode and xenon diode. Determine the baud resistance. So the question asking for baud resistance for silicon diode and xenon diode and germanium diode, and the baud resistance that I get from silicon diode is 16.66 ohm, and baud resistance for germanium diode is 100 ohm. So let's see at my graph that I plotted myself. So for silicon diode, because of forward bias, the graph should be like this, and the question use a 1 milliampere. So I plot it here and I get 0.61 volt and 0.67 volt, 0.67 amp and 0.61 volt and 0.67 volt, and the current is 4 milliampere and 1 milliampere. And the germanium diode, I get 0.64 volt for 4 milliampere, and 0.34 volt for 1 milliampere. Right. So let's continue for the next question, which is asking for knee voltage. Knee voltage for diode silicon is not 0.58 volt. The knee voltage for diode silicon is 0.58 volt, and the knee voltage for germanium diode is 0.69 volt. So ni wrong lah, ni wrong. Nak makan nak tolak lah. So let's continue for the question D. Construct the circuit in figure 5 with red LED. Adjust the supply voltage until the first visible light is noticed. Measure the firing level for ID and VD. So visible light that I got in purchase is 2.21 volt for voltage, and the current is 3 milliamp for current diode. And the current diode for firing level is 6.57 milliamp, and voltage diode is 2.2 volt. So let's try and purchase. So the value that I get is 2.21 volt. 2.21 volt. Okay. 2.21 volt. See, the diode start to lights up at 2.21 volt, and the current is 3.98 milliamp. And for firing level is 2.21 volt. 2.2 volt. See, the diode start to fill all the color in the diode in the LED. So the next question is about increase the supply voltage on the good brightness is which. Measure the ID and the VD at the bright light. So you can see the result that I got is 2.3 volt and 9.36 milliamp. So you can see that it start to light up clearly, and the result that I got is same with the question. So we continue for the last question, which is for Zener diode. The characteristic for the Zener diode. So these are the measurement that I get from purchase. One box I use 1 volt. So the second box will be 2 volt. So let's try in purchase. So 1 volt. The voltage I get is 1 volt, minus 1 volt, and the current will be 0 milliamp. Let's try for 5. The voltage will be minus 4.99, and the current will be 0.03 milliampere, which is same with this calculation and with this measurement. So after we plot all of this value in the Excel, I will get the output like this. So because our Zener diode is used to be in breakdown region. So the graph should be like this, should be in negative area, not in positive area or up. So the voltage for Z here will be minus 5 volt, which is voltage knee voltage. Okay, that's all for me. Thank you.